Okay, so today's lesson is still factoring, but today they're going to be special products. Now, technically, we can still do it the long way that we did on yesterday's quiz. However, if you're good at recognizing perfect squares, then it's going to make your homework a lot easier. So let's go ahead and take a look at this. So here it's asking you if you can determine if all of these are perfect squares. Now, remember, a perfect square is when you multiply the same number by itself. So, for example, the answer to 1 times 1 is a perfect square. The answer to 2 times 2, 4 is a perfect square. 3 times 3, 9, and so on. So if you're good at recognizing the numbers that are perfect squares, this homework will be very easy for you. So I do recommend just to, simplify your life when you're factoring and in Algebra 2, if you memorize the perfect squares up to 20, it does make factoring easier. So if you were to be able to come out here and say, the perfect squares from 1 to 20 are 1, 4, 9, 16, 25, 36, 49, and just say them all out really quickly, then when you go to do these problems, it'll be a lot easier. You really should know them up to 12 from 3rd grade. 13 and 14, I've got a cool little trick. 13 times 13 is 169. And 14 times 14, if you flip the last two numbers, it's 196. So if you memorize one of them, just rearrange the numbers, and that's the other one. So really, it's memorizing from 13 to 20. And 20 is easy also. 2 times 2 is 4, and put 2 zeros, so 400. So number 1, 8 times 8 is 64. Number 2, 6 times 6 is 36, so it's a perfect square. The factors of 45 are 1 times 45 and 5 times 9, so it's not a perfect square. Notice to get x squared, it's x times x, so it is a perfect square. And then so on. Same thing with the y, for y to the 4th times y to the 4th is y to the 8th. So all of these are perfect squares except for the number 3 and number 7. Okay, so in today's lesson, we are going to learn how to factor perfect square trinomials and the difference of two squares. Now, we saw this when we learned how to multiply them, when we FOILed. Remember, the difference of two squares is going to be just a binomial. So for example, remember when we did this, x squared minus 36? This is called the difference of two squares because this one's a perfect square, 1 and 36. Or even if you had 25 and 49. Notice that this is a perfect square, this is a perfect square, and the sign in between them is a subtraction, and that's where the word difference comes from. When you have a perfect square trinomial, the two numbers on the ends of your trinomial will be perfect squares. The middle one will not. So we'll see some of these in action. Okay, so here is the perfect square trinomial. Notice the first one is a perfect square. The last one is a perfect square. The middle one will not be a perfect square. So notice if you do square root 9, you get 3, and if you square root 4, you get 2. This will take you right into your answer. It's going to be a binomial squared. So if you square root the 9, square root the 4, that gives you your factors. Now, if you didn't realize that 9 and 4 were perfect squares, then what we're going to do instead is we're going to do what we did on yesterday's quiz, where we're going to multiply the beginning and the end, and we're going to get 36. So we'll look for two numbers that multiply to give 36, but who add to give 12. So you can do these the same way, and it's 6 times 6 and 6 plus 6. So then you would take the 9x, if you're doing the trick, plus 6, the 9x plus 6. Remember, when you simplify, notice it's going to go to the same thing for both. So technically we can do this, what we did on yesterday's quiz, or if you realize that this is a perfect square and this is a perfect square, you just square root it and those are your factors. Yes?
How did you get the 2 outside of the parentheses?
In their writing or mine?
In their writing, in the blue.
In the blue. All right, that's their stuff here. What they did here was they did the trick for it where they, I guess, factored it, and then they took the one of this and one of this, and then when we learned how to FOIL this, the perfect square trinomials, I think it had something like, had 2 times a plus b. Don't worry about doing this red stuff here. You're going to either realize it's a perfect square and square root it, or you're going to do it the long way like you did on the quiz yesterday. Did you do factor by grouping or did you do the trick?
Oh, no, I did the trick that you told me.
So you did it this method right here?
That one?
Yes.
Yeah.
Okay. That's a good question. She said, okay, if you see that these are perfect squares, yes, you can just square root them, but you should FOIL it because sometimes it always doesn't make the middle. Okay? Sometimes the ends are perfect squares, but it won't FOIL back to give you the 12. So if you're going to try that, what you're going to do is you're going to square root them and get the square root of 9x squared is 3x. The square root of 4 is 2. So you're going to put whatever sign's here in the middle. And then what you should do is write it 2 times and FOIL it. If the outer and the inner don't give you 12x, then you know you can't do that and you have to do it the long way. Okay? All right, let's try another one. So here is an example of this. So this is where the 2 came from. In just the standard form of it, when you have a perfect square trinomial is going to be the first number squared, then plus 2 times a times b plus b squared. So this is where that 2 came from in their notes. Again, you don't need to break it down that way. Either do it the long way with the factor by grouping, do it with the trick I showed you, or realize that they're perfect squares, square root it, and then just double check that it FOILs back. All right, let's try some examples. Now, if you look at this problem, notice the number 9 and the number 64 are both perfect squares. Because 3 times 3 gives me 9, and 8 times 8 gives me 64. So what we'll do here is we're going to square root the 9, square root the 64, and we're going to see, and then the sign that's in the middle of my binomial is the middle one. And I'm going to write this 2 times. And I'm going to FOIL it, so the square root of 9 and the square root of 64. If this FOILs back and gives me negative 15 in the middle, then I know I can do the trick. Otherwise, I would have to do it the long way. Okay, so here, we're going to multiply this. Actually, all we need to check is outer and inner. So when I do that, I get negative 24 and negative 24x, and notice that gives me negative 48x. I was trying to get 15, so the trick doesn't work here. It's not a perfect square trinomial. All right, on the test next week, I'm not going to give you anything that doesn't work. This one you can't factor, so you would say that it's prime. So this one, this is just demonstrating that you have to check it once you square root it, because it doesn't always FOIL back. Yes?
So when they're saying 2 times the 3x times 8, they're just saying 3x times 8 2 times.
Yes. So for the trick, what they did from the notes is, yes, here's the problem, and plus 15x plus 24. So once you square root this, and you see this is 3x, and that's not 24, it's 64, and that's an 8. So this would be 3x squared for the first term to be a perfect square trinomial. This would have been 2 times the 3x times 8, and then this would have been the 8 squared. So if it worked, this one doesn't work.
So when the signs in the original are negative, positive, that means that the signs in the solution are going to be negative, negative.
Yes. The last term's always going to be positive in these perfect square trinomials. So the signs are either going to be plus plus or minus plus. The last one's not going to be negative in these.
In the actual solution?
It could be negative, negative, but it's never going to be 2 different signs for the perfect square trinomials. Yes?
How is it negative here?
Because this one, the middle term was negative, but this one doesn't work. This one is not a perfect square trinomial, okay? Because it doesn't FOIL back and give me 15, negative 15. It FOILs back and gives me negative 48x. This one I can't factor. Yes?
So whatever on the middle you put as the, like if it's positive in the middle, it's positive in the column.
It's positive in the answer in the 2 binomials. Yes. All right, let's try another example. All right, so again, try to recognize, yes.
Oh, can you go back to the...
Now, here, yes.
I don't really understand when you're putting, what's the answer?
The answer are 2 binomials, just like on yesterday's quiz. So right now, we're just learning to test out if it's a perfect square trinomial. Okay, now let's say this was a question on yesterday's quiz. 81x squared plus 90x plus 25. Now, if this were yesterday's question, you would have had to have multiplied 81 times 25, gotten this huge number, and tried to look for the factors of it that give you 90. So the shorter method for this is realizing that these are perfect squares. We're going to square root. 81 is a perfect square, so that becomes 9x. 25 is a perfect square. It becomes 5. The middle sign's plus, so I'm going to try to write this 2 times, and now I'm going to FOIL it. If it FOILs back and gives me 90 in the middle, this is my factored answer. Okay, so here I'm going to FOIL and get 81x squared. This gives me 45x. The inner gives me 45x. And the last gives me 25. When I add the middle, it did FOIL back. So this is a perfect square trinomial. And the answer, the factored answer is 9x plus 5. You can also write it as 9x plus 5 squared. Yes, Elizabeth.
Does the different numbers of exponents make the equation any different? Like if it was 81x to the 4th power?
Okay, so then we're going to have to factor. So what you'll do is x squared times x squared would, you could square root it. So that is a perfect square also.
Okay.
Yes, Faith.
So our answer would be 9x plus 5 to the square.
Yes.
And we have to say like if it's a perfect square or not.
Okay, in the homework, you're going to have to do that. But on the test, they're all going to be able to be factored. And whether you do it the long way or you do it the trick way, it's up to you. Yes.
So on the test we wouldn't have to say we need to factor, we just put 9x plus 5 to the second power.
Correct. Yes.
But if we do end up doing it perfect square, maybe we have to say perfect square.
No. All right, let's try another. Right now they're just trying to see if you can recognize if it's a perfect square. Okay, trinomial. And here it is, 9x plus 5. And it's squared. Okay, this one, 14, if you look at this, is not a perfect square trinomial. What you would have to try to do is multiply the beginning and the end and find the factors of this number that would give you negative 10. Okay, and this would be probably really big. But right now, for this lesson, all we're trying to do is see if it's a perfect square trinomial, if the trick is going to work for us. If not, we're going to resort to doing what we did on the quiz yesterday. Okay, the next one. Here, if you notice, the number in front of here is 1, and 1 is a perfect square. So yes, this is a perfect square trinomial. And when I square root this and square root this, I get 1x, and then I get square root of 4 is 2. If I write it 2 times and FOIL it, it does go back to my original. So yes, this is a perfect square trinomial. And the answer would be x plus 2 to the second power, or you could just say it like this. Try another one. Okay, here they're doing it just the factoring way, and you can do it that way also. So yesterday, when you did this, x squared plus 4x plus 4, yesterday we were looking for the factors of this that would add to give me 4. So 1 times 4, 2 times 2. You can see it's the 2 times 2, and you can also do it what you did yesterday. Okay, not realizing it's a perfect square. Either way. Here's another one. Notice again, the beginning and the end are perfect squares. So we can either list the factors of 49 and then find the one that'll give me 14. Or I can square root this. Notice the sign in the middle is negative. So it's x minus 7, x minus 7. When I FOIL this, it does go back to the beginning. So it is a perfect square. And the answer to the factoring would be x minus 7 squared, or write it 2 times. So you can do it the other way, what we did on the quiz yesterday. Yes? For this to be a perfect square trinomial, the last number here in your trinomial must be positive. Otherwise, you're going to do it what you did on the quiz yesterday and do it out the long way. So here's the same example, and again the answer is x minus 7 squared. Okay, next one, they want us to check to see if it's a perfect square trinomial. It's looking like it might be because these are perfect squares. So if I go ahead and square root 9 and square root 4, I get this. But now I have to FOIL this because I need to double check that I'm going to get a negative 6. When I do the outer and the inner, I get negative 6 and negative 6, which gives me negative 12x. It doesn't FOIL, so it's not a perfect square trinomial. So I would try to do it the long way to see if I could actually factor it. This one actually can't be factored. And you would say, we haven't encountered any, but if you ever get a problem that can't be factored, you just tell me that it's prime. However, on your test, everything will be able to be factored. Okay? When it can't be factored, then you would use the quadratic formula. Yes?
So if the middle doesn't, if it doesn't match with the middle, do we do it the long way?
Then you would tell me, in this homework tonight, you're just telling me yes or no if it's a perfect square trinomial. So if it doesn't FOIL and give you the middle, then you just say it's not a perfect square trinomial.
So we don't do it the long way?
No. All right, here is a word problem, and it says we have a square piece of cloth, and it's telling us the area. So here, all we're gonna do is factor this. And then after we factor it, we're gonna plug in 11 to find the perimeter. So notice 16 and 9, these are perfect squares. So let's go ahead and try to square root it instead of doing it the long way. So I'm going to get 4x, and then the middle sign is negative, so minus 3, the square root of 9. I'm going to try and FOIL this and see if I get 24 in the middle. So when I do outer and inner, I do get the negative 24. So this is the factors. So this is one of the side lengths, 4x minus 3. So they want us to find the perimeter. So I'm going to make x equal 11. So I'm going to do 4 times 11 minus 3 and get 44 minus 3. So each side is 41. And because it's a square, I can either add 41 plus 41 plus 41 plus 41, or just times it by 4. And I get 164 inches. Okay, let me go to the next slide. So remember, when we're factoring this, we're finding the two numbers that will multiply to give us this. Because area of a square or a rectangle, for a square, it's side squared. So basically, if you realized that when you factored that, it gave you a binomial squared. So right here, this binomial is the side length. Because side times side gave me this trinomial. So then once I factored it and found out the side length, remember the difference between area and perimeter, area you multiply the side lengths, perimeter you add them up. Does that help? So area is side, side. So in a square, all the sides are the same. Let's do numbers here. Let's say this is 3, and this is 3, and this is 3 because it's a square. So to find area, you do 3 times 3 and get 9. But to do perimeter, you would do 4 times the side length. So what I did here was they had already given me the area, which was 2 binomials multiplied, which was this. So this times itself gave me this.
Why 3 times 3?
Because I just made up a problem, just to demonstrate to find an area of a square with numbers, without letters. So I just made up this number and said that this square has a side of 3. Actually, okay, I could do it with, well, I can't say that it was 11 because it wasn't 11. The side was actually 41.
Getting the area and perimeter switched up.
Okay, areas multiply. So when we undid and factored that trinomial, we got the side length. And then once we found out how big one side was, then we can add up all 4 sides to find the perimeter. Okay, all right, show you their work. Yes.
1, 2, 3.
All right, so here they factored it. Their tablecloth. So let's look at another. And they got what I did. And now this is one side length. Remember, whenever you calculate perimeter, you are going to add up all the sides. So 4x minus 3 is on all the sides. They said to plug in 11 for x. So what I did was I just did it one time, and then I multiplied my answer by 4. It was a square example. So here, they plugged it, or they actually distributed it before. It said it, and they got the same answer I did by doing it individually. So this would be an application problem. In the problem, let's look at, We're going to now look at here a street problem. Here's another example. Again, you would FOIL it, or not FOIL it, factor it, and then plug in x equals 3. So here, it's sheets. A company produces. Okay, so here is another application problem. We have a company that's producing a square sheet of aluminum. Okay, again, notice all of these are squares because remember, our answer is when we factor this trinomial is a binomial squared. It's going to be the same answer twice. So if you square root 9, square root 1, we get 3, and the middle sign was plus. So 3 plus the square root of 1, which is 1. And then if I write it again, these are going to be the sides of my aluminum sheet. So here, if it says to find the perimeter, what I'm going to first do is I'm going to take my side length, my 3x plus 1. I'm going to put in this 3. And then I'm going to multiply and add. And I can see that each side of my aluminum sheet is going to be 10, giving me a perimeter of 4 times 10, which will be 40. Now, if you look at their slides, what they're going to do first is they're going to distribute 4 to this, and you can do it that way also, and get 12x plus 4, and then plug in the 3, and 12 times 3 plus 4 is 36 plus 4, which also gives a perimeter of 40.
You have to put meters, right?
Correct. The units on perimeter are just whatever they are. For area, it was usually squared. Notice the m squared up here.
I'm confused about the side one.
Okay, let's go back. Okay, let's go ahead and take a look at the difference of two squares, which is also the other special case. So when we FOILed problems back in the beginning, I guess, of chapter 7, I guess it was, when you had two things that were like this, let me do x plus 6 and x minus 6. Remember what happened with the inside and the outside, how they canceled out? Okay, so all of our answers, when it's the difference of two squares, it's just going to end up being a binomial answer. So notice when I FOIL this, I get x squared, negative 6x, positive 6x, and then here gives me negative 36. Notice here, these cancel out, and then my answer is the difference, subtraction sign, of two perfect squares. So when you start out with your problem that looks like a binomial, you should immediately check to see if the first number and the second number are perfect squares. If they are, just square root it and turn it into two binomials with opposite signs. And let me look at another example. So for example, this one, 4x squared minus 9. Notice it's a binomial. Notice both the 4 and the 9 are perfect squares. So to answer this question, I'm going to square root this, square root this. My answer to this will be 2x minus 3 and 2x plus 3. One will have a subtraction, one will have an addition, because when I FOIL this, the middle term will cancel away. Okay? If this is a plus sign starting out here in the middle, you can't factor it. It must be subtraction. Think of the name. It says difference of two squares. Let's try another example. Okay? Notice here, it's going to have two perfect squares, and the powers on the variable must be even, and it's got to be a subtraction sign. So notice this one. Is 3 a perfect square? No. This one is not the difference of two squares. So you would say, no, it's not the difference of two squares. We're going to learn in lesson 7-6 or actually we already learned, we could factor out a GCF. What's the GCF that we could pull out of this one? 3. So this one, we can't turn it into binomials, but we could divide it by a GCF. So we could factor it in that fashion. All right, next one. Is 100 and the number 4, both of those numbers, are they perfect squares?
Yeah.
What's the square root of 100? 10. 10 times 10 is 100. And then that becomes 10x. What's the square root of 4?
2.
So 2y. And then the other one will have a plus sign. So as long as this number and this number are perfect squares, and the variables have even exponents, and this is a subtraction, it's easy. You just square root, put 1 plus, 1 minus. Let's look at another example. Notice this one. Again, my exponents are even, and both of the numbers are perfect squares. So this would turn into divide the exponent by 2. And that's the first one. And then the other one's a plus sign. And you're done. Here's another one. It's backwards, but they're still both perfect squares. Square root of 1 is 1. Square root of 4 is 2. Almost done. Here again, perfect squares. Exponents are even. Subtraction sign in the middle. Constants or coefficients are both perfect squares. Square root of 1 is 1. 8 divided by 2 is 4. Square root of 49 is 7. 6 divided by 2 is 3. The other one gets a plus sign. And you're done. Another one, both perfect squares. However, look, we've got an odd exponent. So this one's not a perfect square. It's not the difference of 2 squares. And that's the end of the lesson. Now, tonight's homework I think is pretty basic. You're just checking to see if they're perfect square trinomials or the difference of 2 squares. If it is, you're going to factor it. We are going to spend tomorrow reviewing this and understanding, making sure you have the concepts down. Okay, then Monday we will start a new lesson. So homework tonight is practice A. We'll go ahead and take a look at it, see how many problems are in it.